One of the things that you guys learn about this week is circles. And we actually don't really do much with circles in this class. You basically hit on it this week and then you don't really see it again. But if you go on to pre-calculus, it does come up again. So it's one of those things that we kind of introduce because you're going to see it again in pre-calc if you are heading that way. So pretty much everybody knows what a circle is, but it actually has a mathematical definition. And so we have like a geometric definition and then like an algebraic definition. And basically, in the world of algebra, if you've got like an XY grid, a circle is a set of all points in a plane, and a plane is a flat surface. So that's basically your graphing area. So it's all points on your graph that are equidistant, and equidistant means equal distance. So they have the same distance from a fixed point called the center. So basically you have a center, and then your circle is formed from all the points that are the same distance from that center, and that distance is what we call the radius. And so you can see the connection here when you're on an XY plane, that you have your center, which we call h comma k. R is your radius, and then you have an ordered pair xy, and every point on that circle is part of that ordered pair xy and has that same distance from the center. So we get our equation for a circle from the distance formula. So you learn about the distance formula. I don't remember if that was this week or if it came up last week, but we have this distance formula. D equals the square root of x minus h squared plus y minus k squared. And the distance formula comes from the Pythagorean theorem. So the Pythagorean theorem gives us the distance formula, and then when you use, and you know the fact that your distance is the radius, and you use the distance formula with those 2 points on the circle, that gives you your equation of a circle. So basically you get the equation of a circle. If you can go all the way back to the Pythagorean theorem to get it. And I'll just draw, if you did like a Pythagorean theorem on that triangle formed from the center to some point, that would give you your equation for a circle. And so what we do is we basically take the distance formula and square it, and then that's the form that we use for a circle, and this is called standard form. And standard form of a circle is nice because you can basically read off of it your center and your radius. So you can figure those out without having to do much math at all. The only thing you need to do is take the square root of r squared in order to get the radius. So it's very minimal math in order to figure out the center and the radius. And if you have an equation and you know the center and the radius, it's like one step to get your equation. So standard form of an equation for a circle is really, really nice. So what we do in this class is basically just finding the center and radius of a circle and just working with the formula so that you understand the formula. We don't do much beyond that. Getting deeper into it is covered in pre-calc, where you really talk about ellipses, which a circle is a special type of ellipse. So you get into more details about a circle and all the properties. But here, all we care about is the center and the radius. And so you basically just read it off of your equation. So the way that our equation is written, it's always x minus and y minus. So whatever is in parentheses, you take the opposite sign. So if we have x plus 3, then it's going to be negative 3. And the value for x is h, the value of our center h comma k. And so then we have y minus 1, so 1 is going to be k. So whatever's in parentheses, you take the opposite sign of in order to get your h and k. So our center is h comma k, and negative 3 comma 1. Then what it's equal to is r squared. So r squared is equal to 16. So to get the radius, you take the square root of both sides. That's why we had to learn about how to solve equations by taking square roots. And we can't have a negative radius. So normally when you take a square root, you get a plus or minus, but a radius is a distance, and distance can't be negative. So we only use a positive number. So the radius here is 4. The square root is 16. So in the equation on the right, in parentheses of the x, we have minus 1.5. So that's going to give us a positive 1.5 for h. With y, we don't have any number in parentheses at all. It's not y minus anything or y plus anything. So that actually tells us that our k value is 0 because we don't have any number there. So our center is 1.5 comma 0. And then we get r squared equals 2.25. So that's the only spot where you need to use your calculator, is by taking the square root of 2.25. I think it's 1.5, but I'm going to double check. Make sure I actually hit the correct button on my calculator. Yes, 1.5. So our radius is 1.5 units. So if you're given an equation, finding your center and your radius is actually quite simple. It doesn't involve a lot of math at all. The hardest part is just using your calculator to take the square root. So it's really pretty simple. So now we're going to go the other direction. We're going to write the equation for a circle. And here we're being given the center and given the radius. So we're going in the other direction. So the equation of a circle in standard form is x minus h squared plus y minus k squared equals r squared. So you are just literally plugging in the numbers and making sure that you're squaring your radius. So again, it's very simple. You're just doing like one step with math, and that's just squaring a number. The hardest part might be just remembering that it's x minus and y minus. So if you have a negative, it changes signs. So our center is h comma k. That's negative 3 and 2. So we're going to have x minus a negative 3 squared plus y minus 2 squared, and then our radius is 4, so that's equal to 4 squared. So when you subtract a negative, that becomes a plus. So this is x plus 3 squared plus y minus 2 squared, and then 4 squared is equal to 16. So you just plug in the numbers, and then you're just doing very simple math to get your equation. Circles are really, really nice. It's like a nice break from some of the harder stuff that you guys have been doing. It's kind of nice to get a nice easy section. So on the right, we have a center, 6, negative 2. So that's h and k, and then the radius is 6. So it's going to be x minus 6 squared plus y minus negative 2. So subtracting a negative becomes a plus. So I just did that right away. And then 6 is the radius. 6 squared is equal to 36. So you could just do that all in one step. Write your equation, and you're done. Because it's simple enough math. If it was a larger number than 6 that I had to square, like if I had to square like 21, I would definitely use my calculator, but I know 6 squared, so I can just do that in my head, and I have my calculator, have my equation. So these are the easiest types of problems, where you either have the equation and you just have to identify the center and the radius, or you have the center and the radius and you need to write the equation. So we're going to start getting into other types of problems where you actually have to do some sort of thinking and like take your knowledge of geometry to figure out what's going on. So here we're going to write the equation for the circle, but we're not given a center and a radius here. We're given the end points of a diameter. So I'm going to just kind of draw a circle here. It's not going to be a perfect circle. It's not too bad. And then that's my center. The diameter is just the length from one side to the other as long as you're going through the center. So this is the diameter. And so the diameter we use is D, and it's 2r, because you have r on each of the lengths from the center. So r plus r is 2r. So our diameter is 2r. So in this case, we're not given the center and we're not given the radius, but we know 2 points that form the diameter. One of them is 7, 3, and then the other one is 5, negative 1. So let's say if I label this point will be 7, 3, and this one will be 5, negative 1. So I can get the center pretty easily. So the center is actually the midpoint between those 2 points. So our center is the midpoint of the diameter. It's the halfway point. And so you want to use your midpoint formula, which is just the average of the x values and the average of the y values. So you add your x values together and divide them by 2, add the y values and divide them by 2. So I'm going to find the center first because that is the easiest one to find. So it's 7 plus 5 divided by 2, and 3 plus negative 1 divided by 2. So 7 plus 5 is 12. 12 divided by 2 is 6. So h is going to be 6. Then 3 minus 1 is 2. 2 divided by 2 is 1. So k is equal to 1. So I found my center, and it's just the halfway point between our ordered pairs when you're given a diameter. Now the hardest part here, and it's not that it's necessarily hard, it's just that you have to do some work, is the fact that your diameter is equal to 2 times the radius, and so we need to figure out the diameter. So let's think of this formula. I have D equals 2 times R. If I divide both sides by 2, I basically get 1/2 D. Basically, take half of the diameter that is given. That gives you the radius. My phone is blowing up. So, and the diameter you can think of here, the D, is basically the distance between those 2 points on the diameter. So we're going to use the distance formula, take half of that, and that is going to give us a radius. And then really, we want r squared for our formula. So I could go and square both sides to figure out r squared. So if I want to know r squared, if you square 1/4 or 1/2, 1/2 times 1/2 is 1/4. So 1/2 the diameter squared is equal to r squared, and we need r squared for our formula. So d here is going to be, the diameter is the distance between our 2 points. So I'm going to write the distance formula up here. We've got the distance formula is x2 minus x1 squared plus y2 minus y1 squared, and then that's inside a square root. So if we square the distance to get d squared doesn't have the square root symbol because we squared both sides. So when I'm finding my radius, I don't need to do the square root part because I'm looking for the radius squared, and so that's undoing the square root. So that's actually going to make our math a little easier here. So r squared is going to be 1/4 times d squared. So I'm actually going to use brackets so that these don't look too confusing. So d squared, we have x2 minus x1. So x2 is 5, x1 is 7. So 5 minus 7 squared plus y2 minus y1. So I'm literally just taking the second point minus the first point. So that's -1 minus 3 squared. So this is 1/4. 5 minus 7 is -2. So that's -2 squared plus -1 minus 3 is -4 squared. So -2 squared is 4. -4 squared is 16. So this is equal to 1/4 times 4 plus 16. So I'm kind of running out of room here. So I'm going to just kind of move over here. So r squared is equal to 4 plus 16 is 20. So 1/4 times 20 is 20/4. So we can divide that. You can leave it as a fraction, or you can leave it as a decimal if you don't have to round. 20 divided by, actually that's not even a fraction. 20 divided by 4 is 5. I can do that. For some reason I was thinking that was coming out to a decimal. Yeah, so you can do 20 divided by 4 and you get 5. And so now we have all the information we need to actually get our equation for the circle here. So it's x minus h, so that's x minus 6 squared, plus y minus k, so y minus 1 squared, equals r squared, and r squared is 5. So we had to do quite a bit of math. The hardest math was finding the radius. Finding the center was not too bad. That's just the midpoint. But to find the radius, you had to find the distance between the 2 points we're given for the diameter. And we know that half of that is the radius. And then we want the radius squared, so we squared that. And you could find the distance first and get that number, then take half of it and square it, but then you end up with decimals here. Because the square root of 5, if I wanted r, is going to be a nasty number, and it's kind of harder to work with. So if you have a problem like this where you need to figure out the diameter, it's actually probably nicer to use this little formula here. That 1/4 that diameter squared is equal to r squared. And that could save you some heartache from working with square roots. So this is one type of problem that you see working with circles, is they give you the diameter and then you have to figure out the equation from there. This is the second type of equation you might get, or type of, not equation, example. where they give you the center, but then they give you another point on the circle. So we know the center and we know a second point. We still don't know the radius, but in this case, instead of being given a diameter, they're basically allowing us to find the radius. So it's going to be easier than the previous problem. So I'm going to draw a circle again. And my center here, so that is at 3, 1, and then let's say 6, 5. I guess I'm just going to kind of estimate where that is. 6, 5 is right there. It's not perfect. So that's what we're given, and so we can find the radius altogether. We don't have to deal with finding the center because they tell us the center. We just need to use the distance formula to find the radius. And like before, we don't want the radius, we want the radius squared. So we're not going to have to take the square root, because I'm going to go back and basically use very similar to this right here, but instead of h and k, I'm going to use that second point, actually. And then because we're squaring both sides, we're really going to do something similar to this, just with, and actually we're going to have the center there. So we basically can use this equation and then use the center because we know h and k, but we just have to plug in that second point to find the radius. So we can use the equation of a circle to figure out the radius squared that we need. So our equation is r squared, or circle, is x minus h. So x and y in this case, we're going to use that other point that we have. So it's going to be 6 minus 3 squared. And then the equation of circle has y minus k. So y is going to be 5. So it's going to be 5 minus 1 squared. So 6 minus 3 is 3, so this is 3 squared. 5 minus 1 is 4, so 4 squared. 3 squared is 9, 4 squared is 16. 9 plus 16 is 25. So r squared is 25. So then we want to go back, and we're just writing our equation of a circle because we're given the center, and now we just found our radius squared. So our equation of a circle is x minus h, which is for the center, so that's 3 squared, plus y minus k, which is 1, because that's from the center, and then equals r squared, which is 25. So if they don't give you a diameter, but they give you the center, the amount of work that you have to do is much less. Because you can basically use the equation for a circle that you have, plug in what you know, and that allows you to solve for the missing piece. Okay. Now here, this was the type of problem that you would see in like a pre-calculus class. So I'm going to just make a note. This is just kind of a preview of something that you might see if you have to go on a pre-calculus. So we want to write, we're given an equation, we want to write it in the form x minus h squared plus y minus k squared equals c, which is basically the equation of a circle, but not everything is a circle with this form. So if it's equal to 0, so if c is equal to 0, it's a point, basically, because that means your radius is 0, and so you only have the center and you don't have anything else. If c is less than 0, that means you've got a negative radius. It's not a circle or a point. It's basically, that's like the degenerate case kind of thing. It's neither a circle or a point, because you basically have to end up taking the square root of a negative number. You're going to get a complex number. So it's a circle if that value you get that on the right side is greater than 0. And something like this would be no solution if it's less than 0. If it's a point, you write your solution usually x, y, where, and then you write your equation. So there's those are the two different ways that you write the solution if it's not a circle. So we have something here. We need to figure out if it's a circle, and it's not in the form that we want. We have x squared plus y squared plus 12x minus 14y plus 84 equals 0. So this is one of the few times that you have to use completing the square. And that is a skill that is not used very often. It's used basically to get vertex form of a quadratic, or in a situation like this, if you're trying to put your equation in the form of a circle. So it's not used often, but we do need to complete the square here. Now, something like this you would never be quizzed on, but I'm going through it because I know that there's plenty of people that are going to have to go to pre-calc. Now, Amber, I don't know if you have to go to pre-calculus, but those who may be watching the recording, there's plenty of them that have to go to pre-calc, and this is a skill that they're going to need. So at least if they've seen how to do it here, or if you've seen how to do it, so when you go further on, it won't be like foreign. You'll be like, oh, I remember I saw something like this. That's sort of the point here. So how this works is, first we're going to put everything with the x together, everything the y together. So I'm just going to rearrange my equation. So I'm going to have x squared, and then I'm going to move the 12x, and then I'm going to kind of leave a gap. And then I'm going to have my y squared, and then the 14y, and then leave a gap. And then that plus 84, I'm going to subtract it from both sides, so that's on the other side. So I have a minus 84. So I'm leaving these gaps because I'm going to complete the square. So completing the square means you take 1/2 of the middle. So 1/2 of 12 is 6. And then you square it. So then you add 6 squared. And we need to add it to both sides. Because you have to, if I'm going to add a number on the left, I have to add it to the right for it to be the same. So I'm adding 6 squared on both sides. I'm going to do the same thing here with the negative 14. So I'm going to take half of negative 14, which is negative 7, and then I'm going to add negative 7 squared on both sides. Should have moved over a little bit left here. Kind of should have not centered so much. So that's the completing the square process. And the x squared plus 12x, and that would be plus 36, that factors to x plus 6. So basically, you're doing this so you can get something that factors, and then whatever that half part is, that's going to be in your factored thing. So that's going to be x plus 6 squared. So now that's given us the x value, the center, which is negative 6. And then we're going to have y minus 7 squared, because that minus 7 here goes right there. So now we know the y value of the center is 7. And then we need to do negative 84 plus 6 squared plus negative 7 squared. So that's negative 84 plus 36 plus 49. And this is equal to 1. So we got something, 1 is a positive number, so this is a circle because it's not equal to 0 and it's not less than 0. So we have a circle so we can identify our center and our radius. So our center is h comma k, opposite sign, so it's going to be -6, 7. And then our radius is the square root of 1, which is equal to 1. So our radius is 1. Your circle is equal to r squared. So this is an example of showing how you can use completing the square, which we don't cover too much. It's covered, but you're not going to be asked to really do that in a quiz or anything like that, or certainly not on like the midterm or the final. We focus more on the other types of solving quadratic equations and working with that. But this is one point where that skill comes in handy, and this is something that you look at in pre-calculus. So now I have one last example, and this one's a word problem, and I'm actually going to use technology for this. So we've got, this shows you where this is useful in real life. It's an example here we've got with a fire. This actually works with earthquakes as well, because usually what happens, specifically with earthquakes, is that you'll have your counter, your earthquake thingy that, like, I don't know what they're called, seismic monitor or something like that. That whatever goes with the seismic waves. Seismic, I don't know what it's called. So you'll have one of those, and then it's detecting vibrations in the earth and earthquakes, and it can detect that there is one, and it knows it's a certain distance away because it uses some math to kind of figure out, well, how far away was that? I determine the shake, but it doesn't know which direction it is. So you know it's some distance away. So it's like a distance away, like a circle around you. You just don't know which direction of that circle it's located. And if you have many of these, and you can figure out where the earthquake occurred by where all of these circles intersect. And it's the same thing here with the fire. We've got 3 fire observation towers, and they're located at 3 different points on a map. And so basically, let's see, I'm going to try. We've got A somewhere here, B somewhere up here, and then C is, I drew my circles really badly because I'm just kind of here, and then C is somewhere here. So basically, we've got the centers, and then we have their distances. So A is 17 kilometers, so that's going to be bigger. B is 15, and then C is 13. So C is the smallest one, and then B is something like that. So basically, you have these circles formed around these locations, and the overlapping point between all 3 circles is the location of the fire. So the fire is where these circles overlap. So in order to graph these 3 circles, we basically need to get the equation of the circle, and then we're going to graph those 3 and then figure out where that center is. And so this is where we're going to use technology, because I'm not going to graph this by hand. But we're given the center, and we're given the radii, which are these distances. So these are the radii, basically, the distances in kilometers. So we have everything we need to write our 3 equations. So equation 1, or I should say circle A. So circle A has a center of x. It's -6, so that's going to be +6 squared. And then we have y minus 14, so that's going to be y plus 14, so it's the opposite. And then this is equal to 17 squared. B, that equation, so b is at 14, so that's x minus 14 squared. And then y is at 10, so that's y minus 10 squared, and that's 15 squared. And then c, we have x minus a negative 3, so that's plus 3 squared, plus y minus 13 squared, and that's equal to 13 squared. So we have enough information to get our equations, and now we're going to graph those. So we're going to go to Desmos.com. That is my favorite graphing tool. So I'm going to try to, there we go. So I've got it up. I'm going to click Graphing Calculator. And then I'm going to enter in these three equations. Grab my keyboard. So, and I can type it exactly as I see it. So parenthesis x plus 6, parenthesis, and then I can get a shortcut to an exponent by using the caret symbol, which is above the 6. So you hit Shift 6, and that gets you up in the exponent. And then I hit an arrow to get out of there. Plus y plus 14 squared and equals 17 squared. So I'm going to zoom out so you can see our first circle. Now I'm going to put in the second one. We've got x minus 14 squared plus y minus 10 squared equals 15 squared. Okay. Second circle. Not too bad from my drawing. It's not so far off. And then the last one, x plus 3 squared plus y minus 13 squared equals 13 squared. So, yeah, my drawing's not too bad. I did the terrible circles, but I did a decent job kind of showing what it would look like. So our fire here is at where all three of these intersect. And so you can see that when I click on these, it kind of marks that value, and it's 2, 1. So usually you would do this a distance. We just use random numbers here, but you could be doing this with like GPS. You can use a latitude and longitude, and you can use that as your latitude would be your x, your longitude your y, and then you can figure out the exact GPS coordinates of where the fire started based off of the observation. And the same thing goes with earthquakes. You have your little systems everywhere monitoring the seismic waves. When they determine that there is an earthquake, you can look for where all of your circles intersect, and then that's the location of the earthquake where it started, and that would give you your longitude or latitude or your GPS coordinates for where it started. So if you're into that kind of science, it's pretty simple math, especially if you have a way to graph it. You know, it's pretty easy to find that coordinate. Solving something like this is more complicated. You basically have what's called a system of equations, which is a system just means you have more than one equation that you have to consider. And in order to solve something with 3 equations, especially something like this, is we have like different methods, and you learn about it in week 8, but in pre-calculus you actually spend 2 weeks on it learning how to solve something like this, and there's different techniques. That's the hardest part, and usually if you have lots of, let's say it is an earthquake and you have like 8 of these, you're going to have 8 different equations. You're not going to want to solve that by hand. So most of the time we use technology to solve these, but knowing how to write the equations and what it means is really important. So this is one of the reasons why we kind of introduce you to circles, and then we cover it in pre-calculus, because people take pre-calc and they usually end up having to go into some sort of science, and they could be going into geology where they study earthquakes. They could be going into physics, where they might have to talk about this kind of thing. I mean, you never know where somebody's going to go after they take these classes. So we just try to get you to learn some skills just in case you may need it, or for the people who do need it, that they'll have some sort of background in it. So that was my little spiel on circles. Do you have any questions on any examples? I wanted to make sure I got through all of it before we ran out of time, but I could certainly go back to an example if you have specific questions.